So, have you seen how much easier JSON is to work with compared to XML? I mean, just look at this mess of tags versus clean key-value pairs.
Yeah, JSON definitely looks cleaner. But XML has its uses, especially for complex document structures.
True, but let's be honest, most modern APIs use JSON because it's lightweight and easy to parse. And let's face it, who wants to sift through all those closing tags?
Still, XML can handle more intricate data types and relationships with namespaces and schemas.
Sure, but that complexity comes with a price, performance overhead and verbosity. Have you tried parsing large XML files? It's like wading through molasses.
I guess speed is crucial in many applications now.
Absolutely. And don't even get me started on how readable JSON is. You can pretty print it easily and see your data structure clearly. Try doing that with an unwieldy XML blob.
JSON does make debugging easier.
Exactly. Plus, JavaScript folks love JSON since it's native to their environment. That interoperability is huge for web services. Now, imagine if we had to constantly convert between XML and JS objects just to display something simple on a web page.
The conversion overhead could really add up.
It sure does. And think about tools support too. There are so many great libraries out there for handling JSON efficiently. Want to serialize some data quickly? Just slap together a few key-value pairs, and you're good to go.
Makes sense why JSON dominates in newer projects then.
Speaking of efficiency, have you looked into binary formats like protocol buffers or message pack? They're designed to serialize data in a compact form, which is great for network transmission and storage.
Yeah, I've heard they can be much more space efficient than text-based formats like JSON.
Absolutely. Binary formats can significantly reduce the amount of data sent over the wire, which means faster transfers and lower bandwidth costs. And because they're optimized for machines, they tend to be quicker to parse as well.
That sounds useful, especially for mobile apps where every byte counts.
Exactly. Plus, with binary formats, you don't have to worry about encoding issues or parsing text, just raw bytes that get directly translated into your application's data structures. Have you ever worked with them before?
Not extensively, but I've dabbled a bit with protocol buffers.
Nice. They're pretty powerful once you get used to defining your message structures in protofilas. The tooling around them generates classes for different languages automatically, making it super convenient for cross-platform projects.
True. The automation aspect could save a lot of time.
Definitely. And let's not forget about efficiency gains from fewer characters being transmitted and parsed. In high-throughput systems, those little bits add up to significant performance improvements. Speaking of defining message structures, have you explored schema definition languages like Avro or Thrift? They allow you to define your data models in a way that's both human-readable and machine-processable.
I've heard of them, but haven't delved deep into using them yet. How do they compare?
Well, both Avro and Thrift provide robust ways to describe your data schema. With Avro, you can define schemas in JSON format, which makes it very accessible. And the schemas are embedded with the data itself, so you don't need external metadata to parse it.
Embedding the schema sounds handy for versioning and compatibility.
Absolutely. Wow. This feature is particularly useful when dealing with evolving data structures over time. It ensures that old readers can still understand new data formats without breaking existing systems. Have you seen any practical examples of this in action?
Not many, but embedding schemas seems like a smart approach to maintain backward compatibility.
Exactly. On the other hand, Thrift offers similar capabilities but uses its own idle interface definition language. It's more verbose, but gives you fine-grained control over the serialization process and supports multiple languages natively.
That level of control could be beneficial for complex systems.
Definitely. Both approaches help ensure that your serialized data remains structured and understandable across different environments and versions. It's all about finding the right balance between flexibility and strictness based on your project needs. Speaking of structured serialization, let's talk about performance. Serialization and deserialization can really impact application performance, especially in high-load scenarios.
Definitely. I've noticed that in some of our more demanding applications, the choice of serialization format can make a big difference.
Exactly. Binary formats like protocol buffers or message pack are generally faster because they're optimized for machine reading and writing. Text-based formats like JSON or XML can introduce overhead due to parsing and string manipulation.
That overhead can become significant in real-time systems.
Absolutely. In real-time applications, every millisecond counts. Efficient serialization can reduce latency and improve overall throughput. Have you seen any benchmarks comparing these formats?
Some basic ones, but detailed comparisons would be really helpful.
Agreed. Detailed benchmarks can show how different serialization methods perform under various conditions, like varying data sizes or network latencies. Knowing these details can guide us in choosing the best approach for specific use cases.
Especially when balancing between readability and performance requirements.
Right. For example, while JSON is human readable and easy to debug, it might not be the best choice for high-frequency trading platforms where speed is critical. Understanding the trade-offs helps in making informed decisions. Speaking of use cases, have you thought about what serialization format works best for REST APIs? It's a common scenario where we need to balance ease of use and performance.
Yeah, JSON seems to be the go-to choice for most REST APIs due to its simplicity and wide support in web development.
Absolutely. JSON is lightweight, easy to read, and integrates seamlessly with JavaScript, making it perfect for client-side processing. Plus, it's supported by virtually every modern web framework.
But are there scenarios where another format might be better suited?
Certainly. If you're working on an API that requires high performance and minimal bandwidth usage, binary formats like protocol buffers or message pack could be more suitable. They reduce payload size and parsing time, which can be crucial for mobile or IoT applications.
That makes sense, especially when dealing with resource-constrained devices.
Exactly. Another consideration is the ecosystem around your API. If your primary consumers are developers familiar with certain tools or languages, aligning the serialization format with their comfort zone can enhance adoption and integration.
So it really depends on the target audience and performance requirements.
Precisely. And let's not forget about future-proofing. Choosing a format that supports schema evolution can make maintenance easier as your API grows and changes over time. Have you encountered situations where switching formats was necessary?
Not yet, but understanding the pros and cons up front can prevent headaches down the line.
Agreed. Wow. Careful consideration at the design phase can save a lot of trouble later on.